Welcome to Lesson 5, where we stop tuning user space and start tuning the kernel itself. Below your accounts, below sudo, below SSH, Linux exposes roughly 1,000 parameters under proc sys. About 30 of them actually matter for security, and the defaults are tuned for compatibility across servers, desktops, embedded and containers, which means conservative, not safe. By the end of this lesson, you'll have a single file, etc. sysctl.d 99 hardening.conf, covering network, memory, process, and file system attack surfaces, persisted, applied, and verified. So let's ground this in mechanics. Everything under proc sys is a kernel parameter. Read or write a file, and you've touched the live kernel. The sysctl command is just a nicer front end to that file system, and you really only need 4 moves. List with sysctl.a, read by name, write with w to test at runtime, and then persist by dropping a file into exary sysctl.d. One rule, never edit, etc. sysctl.conf directly, always use a numbered drop-in, like 99hardening.conf. That's the file we'll be building for the rest of the lesson. First file in that drop-in, the network stack. 10 knobs, each closing a specific stride category. RPBot filter set to 1 drop spoofed source IPs. Accept source, arc root, and accept redirects, both v4 and v6, go to 0. That's decades-old MITM territory we simply refuse to honor. TCPR, syn cookies, and ICMP har, echo har, ignore. Broadcasts kill the classic DOS amplifiers. Log Martians gives you a paper trail when something impossible shows up on the wire, and TCP part timestamps off stops leaking your uptime via jiffies. Compatibility defaults out, suspicion in. From the wire we move inward to memory and process. Almost every kernel exploit begins with an info leak, a pointer, a symbol, a DMSG line that defeats ASLR. So kp restrict goes to 2, dmesg restrict to 1, print k quieted down to 3, 3, 3, 3. Then we slam the lids, unprivileged BPF disabled, PA trace scope to 1, kexec load, charge disabled, randomize VHR space at full 2, and perf event, chasham paranoid at 3. One caveat, perf event, paranoid 3, will break perf top, so drop to 2 only if you actually profile this box. From process down to the file system, and this is where .tmp bites. Hardlink and symlink races in world-writable directories are textbook local privilege escalation, so fs.protected.hardlinks and fs.protected.symlinks both go to 1, and fs.protected, FIFOs and fs.protected are regular to 2, which covers the cross-user case. Then fs.disuid dumpable to 0, no core dumps from setuid binaries, because those dumps are an info leak waiting to happen. And kernel.core uses byte ID to 1, so any dumps you do allow elsewhere don't clobber each other. 6 knobs, fully backward compatible, and worth verifying because defaults drift between Ubuntu and RHL. So here it is, every knob we've discussed, consolidated into a single file you drop into. Etc. sysctl.d 99 hardening.conf. Network block at the top, memory and process in the middle, file system at the bottom, all commented so you can audit it in a code review without context switching. Copy it verbatim onto every server you operate. The only line you might tweak is kernel.perf has event chart paranoid. Leave it at 3 unless you're actively running perf, in which case drop it to 2. Dropping the file is only half the job. You have to prove it loaded. A sysctl change lives in one of 3 states, runtime only via sysctl.w, which evaporates on reboot, file loaded with sysctl system, which applies now and at boot, and reboot survived, which is the only state that actually matters in production. Use w to smoke test a single knob against your app, then persist it. And always reboot once after persisting. That's how you catch a typo before it catches you at 3 in the morning. Now, honesty time. Out of the 30+ knobs we're setting, 2 of them can break legitimate workflows. First, perf quark event paranoid set to 3. That locks down perf top, PySpy, BCC tools, BPF trace, anything doing flame graphs. If you actively profile in production, drop it to 2. Otherwise, 3 is the right answer. Second, unprivileged BPF just disabled set to 1. That kills rootless eBPF, which hurts Cilium without privileges, unprivileged Falco, and some service meshes. On Kubernetes hosts, leave it at 0. On bare metal and VMs, set it to 1 and close a major exploit class. Test one host for 24 hours before you roll the fleet. Here's the bonus you didn't ask for. This single file knocks out a big chunk of the CIS benchmark for Linux. Sections 3.2 through 3.4 are almost entirely sysctl tuning. Source routing, ICMP redirects, Martian logging, broadcast echoes, reverse path filter, sign cookies, all already in our config. Add ptrace scope and ASLR from section 1.5, and you've got at least 8 L1 controls passing for free. Lesson 10 walks the full benchmark, but compliance auditors will already be happier after this one file lands. Before we wrap, 5 gotchas that have each cost me half a day. 1. Never edit sysctl.conf directly. Package upgrades will silently overwrite it. 2. rpproc filter yasta to 1 breaks asymmetric routing on multi-NIC hosts. Use loose mode, value. 2. 3. Syn cookies mitigate syn floods, but hide them. Monitor TCP/bar max, char syn tar backlog separately. 4. Drop files in sysctl.d must end in .conf, or they're silently ignored. 5. Host sysctls don't cross into containers. That's a security context or containered config, not a kernel knob. So let's recap what you actually built. 6 skills, 30+ knobs, 1 persisted file. You learned the chuck proc sys interface and the 4 sysctl commands that matter. You hardened the network stack against spoofing, tampering, denial of service, and information disclosure. You locked down kernel pointers, DMESG, ptrace, and BPF on the memory and process side. You closed the OTTMP symlink races with 4 fs.protected toggles. You wired it all into 99hardening.conf, and you mapped roughly 30 settings to 8+ CIS Level 1 controls, a free compliance baseline. Next lesson, file system permissions and ACLs, the final layer of stage 02 before we step into mandatory access control. Lesson 5 is in the books. The kernel is hardened, your 99hardening.conf is persisted, and you've got a CIS-mapped baseline to show for it. Next up, Lesson 6. Chmod and chown beyond the basics, a permission audit across cha etc., sha, var, jot, log, and home, and POSIX ACLs with setFacle and getFacle for granular access. That closes Stage 2, then Stage 3, mandatory access control and audit. Load it up when you're ready.